the queen of bridges, dramatically spanning a mile of turbulent water. But its birth was a fiery mix of high-minded idealism, brilliant engineering, and daring construction work. Now, the Golden Gate Bridge on Modern Marvels. Its grandeur is often shrouded in a creeping cocoon of dense fog. But when the fog lifts in San Francisco, the Golden Gate Bridge beckons as a shining example of how engineering and architectural design can work together to transform functionality into artistry. When completed in 1937, it instantly became symbolic of the American dream.
Well, certainly the Golden Gate Bridge is a critically important piece of transportation infrastructure. It's also a remarkable engineering achievement, but I think the thing that sets it apart from other big bridges around the world is the love affair that the people of San Francisco, of California, even the United States have with this bridge. And our workers say the Golden Gate Bridge is alive and that it lives and breathes. And when you get out there on the bridge, you find out that that's really true. It does.
We estimate we have somewhere between 9 and 14 million visitors a year who either come to walk it, ride a bicycle over it, drive over it, or just come and park and look at it and really enjoy the experience of seeing this modern marvel of engineering. The bridge is a major attraction.
San Francisco's signature landmark spans the mouth of the picturesque Golden Gate Strait and inspires awe as the world's most majestic example of suspension bridge design.
What that means is you have main suspension cables that start on the land, that rise up over the top of a tower, drape down in mid-span, rise up over the next tower, and come down again on land. On the end of each individual cable is a mass of concrete that holds it to the ground. Each chunk of concrete weighs about 120 million pounds. So it's a tremendous weight to hold a tremendous force, because the entire weight of the bridge is hanging on those cables. There are vertical suspender ropes that drape over the top of the main cables, and those are spaced every 50 feet along the length of the bridge. And those suspension ropes, if you wish, are what hold the deck up, the deck that we walk and drive across.
San Francisco's demands as a port city dictated the bridge's colossal dimensions. During the initial planning stages, the Navy required the clearance under the bridge at high tide to be a minimum of 220 feet. When first finished, the Golden Gate was far and away the biggest suspension bridge in the world. The total length of the bridge, including the approaches, is 1.7 miles. The main suspension span between the towers is 4,200 feet long, which was 700 feet longer than that of the previous record holder, New York's George Washington Bridge.
It stayed the largest bridge in the world until 1964, so 27 years later, when the Verrazano-Narrows Bridge opened in New York City, and the Verrazano-Narrows Bridge is only 60 feet longer than the Golden Gate Bridge. So if you don't think that was on purpose, today the Golden Gate Bridge is the 8th largest suspension bridge in the world, and some of the big bridges are truly much, much bigger. The Akashi Kaikyo Bridge in Japan is now the largest suspension bridge in the world, and it's at 1.5 times the size of the Golden Gate Bridge. But no bridge anywhere captures the hearts and minds and spirits of the people who visit it like the Golden Gate Bridge does.
Adding to the bridge's artfulness is the arch at its south end. It wasn't necessary from an engineering standpoint, but was incorporated into the design for the sole purpose of preserving historic Fort Point, a relic outpost from the Civil War.
It would have been cheaper to demolish the fort, and there's no reason to save the fort other than respect for those that went before us.
The origins of the need for the Golden Gate Bridge can be traced back to 1848, when gold was discovered in the hills northeast of San Francisco. As gold fever attracted legions of fortune hunters, the city's population soared more than 7,000% in just 2 years. With bountiful wealth came all the pleasures of the flesh. Drinking, gambling, opium, and prostitution helped give San Francisco's waterfront, the Barbary Coast, a reputation for hedonistic abandon. To puritanical America, there was a suggestion of divine retribution when the earthquake and fire of 1906 caused destruction of biblical proportions. of the ashes arose a people even more determined to revel in the zeal of independence.
There's an attitude in San Francisco that developed after the earthquake of 1906 that said, you know, we've been knocked back, but we are never going to be fallen, and we are never going to stop, and we're always going to be out on the cutting edge. And this was a chance to do something that people said couldn't be done, and that's usually what San Francisco does best.
San Francisco rebuilt, and soon the streets teemed with one of the 20th century's most life-altering innovations, the automobile. Mass-produced motor cars allowed the common man to chart his own course. The concept was all American, and weekend jaunts quickly became a lifestyle. But in San Francisco, it was becoming increasingly hard to escape the city.
The only way to cross the bay was by ferry. And back in 1919, I think there were something like 123,000 ferry car trips in a year. By the late 20s, it was up to 2.5 million. I mean, it was a tremendous growth. Bottom line is, traffic congestion is not a new phenomenon. It occurred here a very long time ago.
In the spring of 1919, San Francisco witnessed one of the largest traffic jams in history. An overwhelming flood of cars converged waiting for ferry service, triggering delays up to 18 hours long. The only alternative was to circumvent San Francisco Bay with a very long drive.
If you wanted to drive to the North Bay, you literally had to drive from San Francisco all the way down to San Jose, then back up on the east side and over across the top. Today, with all of our freeways, on a good day with very little traffic, that's still going to take you about 2.5 to 3 hours. Back in 1920, 1925, that must have been an all-day trip, if not longer. And so the ferries were tremendously important.
Until the 1920s, people generally accepted that it would be impossible ever to bridge the Golden Gate. But the area's growth finally demanded that the impossible at least be attempted. The city turned to Joseph Strauss, a renowned bridge engineer who reveled in accepting monumental challenges. Strauss's peers considered him arrogant, short-tempered, and perhaps the most brilliant bully of his time. But he also had a solid record of success. Strauss had built bridges for San Francisco in the past, like the 4th Street Bridge. His work was structurally sound, but notoriously unattractive. After 3 years of computations and research, Strauss came up with a master plan. A large, lumbering monstrosity with little beauty or practicality. Reaction was universally unenthusiastic, but he was hungry for the prestige a Golden Gate Bridge would bestow. Joining forces with a quickly organized team of academic engineers, Strauss submitted new designs based on the suspension bridge concept. The design finally selected offered unusual architectural beauty, along with the solution to the Bay Area's traffic problem. But for those who profited from the ferries, the proposed bridge represented an enormous threat.
The Southern Pacific Railroad Company owned the ferries, basically, and they had bought up all the franchises, and they were making money hand over fist, so they certainly didn't want any bridges built.
Southern Pacific mounted over 2,300 legal disputes. The Bay Area's enraged citizens countered with an area-wide boycott of the ferry system and forced Southern Pacific to drop its nuisance lawsuits. But there was another, more powerful force also blocking construction.
In the early days, before the bridge was built, the Golden Gate Bridge District negotiated for 7 years with the Department of War at the time over whether there should be a bridge across the entrance to San Francisco Bay. The fear, of course, being that an enemy could come in and bomb the bridge, drop it into the water, and lock the Pacific Fleet in San Francisco Bay and to halt commerce in and out of San Francisco Bay.
The War Department eventually gave in. But in 1929, 9 years after the bridge was first proposed, America collapsed into the Great Depression. There was barely enough money for food, let alone funds for the government to finance the largest bridge project in human history. The proposed cost was a then staggering $35 million. Civic leaders put the fate of the bridge in the hands of the people.
What happened is that they went out to the voters in all of the counties from San Francisco north to the Northern California border and said, would you be willing to basically put a lien against your personal property, your farm, your vineyard, your home, your business, for the security against these bonds, so that if something happens, we build the bridge, it doesn't stand, it falls down, and we still owe money, we're going to come back at you and at your house. And people said yes. I can't believe that today, that people would literally put that kind of faith in an idea.
The Bay Area's civic pride was contagious. Even financial institutions were ready to invest in San Francisco's future.
A.P. Giannini, the Bank of America founder, felt that as a result of the Depression, jobs were necessary, and he offered a $5 million line of credit to go ahead and begin construction of the bridge.
With no government support, the people of San Francisco set out to demonstrate how self-determination and self-reliance could change the world. January 1933. On a barren finger of land by turbulent waters, the president of the Golden Gate Bridge District, William P. Filma, and Mayor Angelo Rossi of San Francisco ceremoniously began construction. For the next 4 years, innovative engineers and daring construction workers would face bad weather, a country mired in economic strife, and sometimes deadly accidents. In 2003, it was estimated that the cost to rebuild the Golden Gate Bridge would be at least $1.2 billion, nearly 35 times the original construction cost of $35 million. The Golden Gate Bridge will return on Modern Marvels. From vantage points all over the San Francisco area, the Golden Gate Bridge's mighty towers can be seen rising majestically above the entrance to the bay. Each steel tower weighs a hefty 22,000 tons. But despite the need for such mammoth support structures, the aim of the architects was to infuse them with a sense of elegance.
Part of the aesthetics of the bridge is how the towers are stepped or tapered as they rise up, and also the struts that cross between the two tower legs. As they rise up, they get closer together.
The tower's 746 feet tall, and all the weight of the bridge rests on those towers. The main cable goes up over the towers, and those towers are in compression, pressing straight down with the entire weight of the bridge. So they're one of the main parts of a suspension bridge.
In 1933, when construction commenced, the creation of the two immense towers was the engineering team's first daunting challenge. The North Tower, partially built on dry land, was a relatively easy task. But creating the foundation for the South Tower was another story.
It was a Herculean challenge. The South Tower is located 1,100 feet offshore in deep water. If you look at a map of California, about half of it drains out this opening. The waterfalls in Yosemite, Shasta Dam, the rainfall in Bakersfield, it all goes out this opening here. The water moves very quickly, so it's a very challenging site. So to construct the South Tower, they built a temporary pier or trestle 1,100 feet out.
The trestle's location so far into the open waters of the Golden Gate made it a vulnerable target for disaster.
Twice they lost that temporary trestle. Once in the heavy fog, a steamer ran into the trestle and took out approximately 300 feet of it. Another time a storm came through, and that storm wiped out about 800 feet of the trestle, almost all of it.
The twin disasters cost over 10 months of hard labor to repair. As the project continued, designer Joseph Strauss made sure that the drama of the bridge's construction was played out before film and newsreel cameras.
And I think that was for two reasons. One is that it was a tremendous engineering feat, and it was an interesting project to watch. But on the other hand, we also had a chief engineer, Joseph Strauss, who understood the importance of public relations, and he understood the power of the media to get people excited about a project, so he was very open to having coverage.
Newsreels covered every aspect of progress on the bridge. The cameras captured how explosives were used to excavate the bottom of the bay to prepare for the construction of the pier for the South Tower's foundation.
This was done by the pilot bomb method. Small pilot bombs were inserted in the guide tube, carefully located over the spot desired. They were then dropped through this guide tube and fired.
These small charges created the holes to place larger charges. After the explosions, seagulls would immediately swarm in to feast on the stunned fish. Once a series of charges had been safely detonated, dredgers went to work to remove the loosened rock. Once enough rock had been cleared, workers began construction on the pier.
They had to pour the concrete underwater, and they did this in the 1930s where it was not commonplace. Once they had the moat fully enclosed, they poured concrete underwater the first about 40 feet within the moat. Then they pumped the water out, and the last part of the concrete pedestal was constructed in the dry, out in the middle of the opening that drained San Francisco Bay.
The creation of the South Pier demanded split-second timing of material delivery on an unheard-of scale. Mountains of sand, cement, and gravel were floated to the construction site in a non-stop armada of barges, then offloaded into enormous concrete mixing facilities built exclusively for the bridge project. Another enormous undertaking was the construction of the massive anchorages to which the bridge's suspension cables would be grounded. Mixed concrete was pumped directly to the locations through movable chutes. Workers then packed and vibrated the thick sludge to remove air pockets in the 12-foot thick blocks, laced with steel reinforcing rods. The work was brutal and relentless, because once the pouring had begun, work couldn't stop or the materials would set improperly. Every hour, 120 cubic yards of concrete were pumped into a twisted maze of reinforcing steel. 3 shifts every 24 hours under searing sun by day and the crackling glare of floodlights by night. Still, all this work was just preparation for the big job ahead. On the other side of the North American continent, the belching infernos of steel mills were forging the body of the bridge. 73,000 tons of steel composed the structure. The huge girders that would support the North Tower were embedded in 98 million pounds of concrete. Massive panels were assembled at the site into 5,000 cells that formed the body of the towers. Then, 600,000 rivets were used to connect the pieces.
Rivets were the fastener of choice in the 1930s. They heated up these steel members. They would throw them. Someone would catch them with a mitt. They'd put them in place, and they then would beat on the end of the rivet to form the head, kind of like the head of a bolt or a nut. So while by today's standard it may seem rather inefficient and cumbersome, it was state-of-the-art in the 1930s.
Some of the riveters, however, were becoming afflicted with mysterious and troubling ailments, referred to collectively as Golden Gate disease. The symptoms included hair and tooth loss, and disorientation and instability. Chemists soon discovered that when the hot rivets made contact with the primer paint on the steel, toxic vapors were emitted and inhaled by the unsuspecting workers. Respirators quickly became standard equipment. But even under such dangerous conditions, work moved fast, often ahead of schedule, thanks to the competitive spirit of the men.
You had to be quick and strong and a lot of guts. Climb like a monkey and be as agile as a cat. And be scared of nothing, work hard, drink like hell, take care of all the women, all the Lucy's. Oh, they loved us.
Workers on the bridge earned up to $11 a day, a handsome salary in 1933. These were highly coveted jobs, while the country was in the depths of the Depression, and men were hungry for work.
I'm told stories by people who are still alive today that worked on the construction of the bridge, that they can remember being at work in the afternoons, and the winds would be really blowing and they'd be tied off so that they'd be safe, but they could also smell wafting up from below them the smell of beans cooking in coffee cans from all of the men who had no jobs and were literally cooking their dinner down below the bridge, waiting for some guy up overhead to fall and lose his job.
In 1934, the longshoremen who worked San Francisco's port decided to strike and included demands that they be afforded the same wages and benefits as the men on the Golden Gate Bridge. Violence erupted, and the government took a hard line against the strikers. The public was alarmed by the attacks on the dock workers. In an unprecedented show of solidarity, the city went on a general strike. For almost 4 full days, all work stopped in San Francisco, from elevator operators, restaurant workers, and office personnel, to the men who were hanging steel on the Golden Gate Bridge. The National Guard was called out, and heavy weapons were aimed at civilians. Finally, before further bloodshed, management agreed to union negotiations, and the strike ended. The defiance exhibited in San Francisco resonated across the United States as work resumed on the bridge that many still believed was an impossible dream. The cement used for the piers and anchorages of the Golden Gate Bridge would be enough to build a 5-foot-wide sidewalk from San Francisco to New York. The Golden Gate Bridge will return on Modern Marvels. Thanks to its elegant design, the natural beauty of its surroundings, and its striking red-orange color, the Golden Gate Bridge is one of the most photographed landmarks in the world. Maintaining the bridge's picture postcard looks is not just a matter of aesthetics, but also of necessity.
The key to everything in maintaining a bridge is keeping it painted. The Golden Gate Bridge is in probably one of the harshest environments of any bridge in the world. And if you're going to compare it to maintaining anything else, it's probably most comparable to maintaining offshore oil platforms. We have an awful lot of salty fog air here and an awful lot of wind and just an awful lot of bad weather in general. And it's a steel bridge and it's subject to corrosion, rust. And in order to prevent that, you need to keep a good coat of paint on it.
Protecting the bridge from the elements includes the precarious job of painting the main cables strung high on the bridge over the bay.
When you're walking down, the cable is only it's a 3-foot diameter cable. Of course, you only get to walk on the top foot of it, and it's rounded, which makes it a little interesting to say the least. You actually have a cable on each side of you to hook into with your lanyards and stuff. I mean, you have to be up there with all your safety gear on and everything like that. It's not like you go up there and like you're walking down a sidewalk.
Main cables being one of the most important elements of the bridge, you don't want to get moisture inside that cable and have any kind of corrosion starting. And so they're up there constantly looking for spots where the paint is broken down and repairing those spots.
Painting the bridge is a full-time operation. There is a rumor that we paint it from one end to the nether end and then we turn around and repaint it back in the nether direction. That's not actually how it's done. We paint based on where it's needed. One of the things that we're very actively involved in is always looking for new paint technologies to improve the consistency and the quality of the materials that are used to make the job easier to do.
The actual color of this bridge, which is known as International Orange, was not selected until construction was underway. Different people had opinions, and back in the 30s, it's no different than today. People shared or voiced their opinions. Some people thought the towers should be black so they would disappear or blend in, which is rather ominous when you think about it today. Others suggested gray.
However, the Navy had very strong opinions. They felt that that would not be visible enough in the gray fog that we have, and they were pushing for the bridge to be painted black and yellow stripes. And all I can say is thank goodness that Irving Morrow, who was one of the design architects on the bridge, just put his foot down and kept saying, no, we need to have something else.
As it turned out, the answer materialized right in front of the bridge's designers, in the form of the primer paint used to protect the steel parts waiting for assembly.
The original paint came from Pennsylvania. It had a shot primer on it to protect the steel from corrosion of red lead. As the red lead aged, it gave it this burnt orange color. And as they were constructing the bridge, people started looking at the bridge and saying, that's a neat color, it fits, it blends in with the hills.
And so when it was all said and done, the Navy bought into the idea that an International Orange Bridge would be visible enough, even in a dark fog, for their ships to be able to see and to go around.
In one sense, the Golden Gate Bridge's strong and vibrant hue reflects the colorful personalities who often risk their lives to help make the bridge a reality.
You know, ironworkers are larger than life. They have a tremendously challenging job. One such iron worker here in the Bay Area is named Al Zampa. He's since passed away a couple of years ago. And Al's famous because he's a member of the Halfway to Hell Club. He fell one day and survived.
I was the youngest, and everybody there was amazed that I could do that work. You know, most guys learn, and they try it, but they couldn't make it. They got scared.
Like all men who work at lofty heights, Zampa understood that the possibility of sudden death was part of the job. A careless slip could send a worker plummeting to his doom, slamming his body against the surface of the water below with the impact of 15,000 pounds per square inch, a force equal to a car hitting a brick wall at 80 miles an hour. Unlike some other projects in the 1930s, when labor was cheap and easily replaceable, safety was a priority at the bridge site.
They wanted to have a legacy of safety. So this bridge required hard hats for all workers. It was the first such project. They developed eye goggles for the workers, special creams to protect against the inclement weather. But one of the things that made it unique is they spent $130,000 in the midst of a Great Depression on a tremendous safety net to protect the workers. So the workers would feel safe, and so that if they fell, they would be saved.
We never had a net before. It's the first time using a net. It was just like night and day. I mean, guys would dance around for long. If they catch them, they'd fire, you know. We'd jump from one beam to the other. I worked up in the steel and didn't realize many times I wasn't even up there. That's how relaxed I was.
The net was credited with saving 19 lives and offered psychological reassurance to most of the men. But on October 20th, 1936, Al Zampa learned the hard way that the protection didn't quite match up to the promise. He fell from an area of the North Tower where the slack fabric was improperly suspended over hard ground.
Well, when I went down, I wasn't scared. I figured the net's going to catch me. You know, where the net was on the ground. And you don't pull it up tight, you know. And I hit the net. I flipped 3 times, you know. And I came down and flat on my back. Cracked 4 vertebrae. Hell, it would have killed another guy. And never even knocked me out.
After 12 weeks frozen in traction, Zampa had to learn to walk again like an infant taking his first tentative steps. His miraculous survival attracted the attention of the tabloids. They suggested a name for Zampa and all the workers saved by the net. They officially became known as the Halfway to Hell Club. Building a bridge is always dangerous work, and accidents like Al Zampa's had been factored into the economic equation.
The rule of thumb is that you're going to lose a person's life for every $1 million of construction. And in this particular case, a $35 million bridge meant you were going to lose 35 people, according to that rule of thumb. Well, up until February of 1937, they literally had only lost 1 individual's life as a result of the construction of the bridge. Unfortunately, in one day, there was a horrible accident, and they lost 10 people.
It was nearing the end of completion, within 6 months of completion, when unfortunately a paving machine fell into the net and it carried 10 workers to their death. It was a tremendous tragedy.
Despite this calamitous accident on February 17, 1937, the bridge's overall safety record exceeded expectations. A total of just 11 lives were lost, fewer than 1/3 of the projected fatalities. As the project continued, some of the most death-defying high-wire acts were yet to come. Since opening in 1937, the Golden Gate Bridge has been closed 3 times because of high winds, some reaching 75 miles per hour. The bridge suffered no structural damage. The Golden Gate Bridge will return on Modern Marvels. From this lofty perspective, the Golden Gate Bridge's cables appear almost delicate, the way they gracefully drape over the 2 towers. But in reality, the 7,650-foot long main cables have to support the massive weight of the suspension spans.
The cable looks like one large wire. It's 3 feet in diameter, but it's actually 27,572 individual wires, each the size of a large pencil lead, if you wish. Those are put into bundles. There's 61 bundles. Each bundle has a little over 1 million pounds of force on it.
7 decades ago, as the bridge was under construction, workers took on the titanic challenge of crafting the main cables. More than 80,000 miles of steel wire were forged and shipped to the bridge site. The wire was specially designed for the Golden Gate Bridge from carbon and alloy steel that met exacting specifications. Samples from each roll were tested for elongation and strength. The workers' goal would be to combine these individual wires to form the main cables.
When they came to the end of the spool, they installed splices. And the splices were just a little compression fitting where they put 2 pieces of wire together with a sleeve around them, and they were crimped together. Splices are stronger than the actual wire, though. They tested them periodically as part of the quality control plan here at the bridge. There are 118,000 splices in these 2 cables.
In the summer of 1935, workers began the mammoth task of suspending the bridge's cables. Initially, shipping lanes were closed, so that the first strands could be dragged across the gate by Coast Guard vessels. The operation was choreographed by radio operators, who directed the pilots through the treacherous waters. Cranes lifted the first small strands to the top. Once they were in place, a mid-span work platform was lowered across the gap. The operation was not a complete success. The platform became stuck on the initial strands. 2 bridgemen volunteered to crawl across the swaying span to free the platform. In the vernacular of the bridgemen, this was called swimming the cable. Once this hazardous task was complete, workers could begin the elaborate process of bundling and draping the mighty cables over the steel tower superstructures. This challenge had to be met at heights up to 746 feet above the water surface, and sometimes in brutal wind conditions exceeding 45 miles an hour. On either shore, the wires connected to massive adjusting rods, while 150-ton saddles over the tops of the towers cradled the cable in place. A network of spinning wheel carriages transported 27,572 wires across the span, 6 wires at a time. Workers placed individual wires by hand into a geometric pattern. Then radio operators transmitted instructions to the opposing bases to tighten the stretch. Enormous reels of fresh wire were woven into the bridge with incredible speed. During one record-breaking 8-hour shift, 1,000 miles of wire were spun over the gate. This spirit of accomplishment allowed the suspension of the cables to be completed in only 191 days. But as the men cheered the arrival of the last strand on May 20th, 1936, they knew the job was far from over. Before the cables were complete, 3,000 wooden pallets were attached, creating a swaying catwalk over the bay. From here, workers could supervise the last stage of the weaving, the compacting of the wire bundles. First by hand, then with the help of hydraulic machinery, the thousands of wires were bonded together and then wrapped in a tight cocoon of steel thread. Every millimeter of the final cable was manicured by powerful metal fingers and then painted to assure a watertight seal. The result was twin cables exactly 3 feet in diameter. From these, the roadway would be suspended with vertical cables, then being manufactured nearly 3,000 miles away to the east. The suspenders dropped to attach a level stretch of steel trusses and roadway panels along horizontal beams, 25 feet apart, 90 feet long, and 8.5 feet deep. Bridgemen rode the enormous steel supports into position as the 1.5-mile track blossomed over the bay. Twisted webs of steel rods were laid across the width of the bridge, welded together, then bathed in tons of concrete, delivered by narrow-gauge locomotives. Giant leveling machines ground the surface to a seamless ribbon of roadway, and painters marked the lanes where traffic would soon flow. As construction on the bridge was about to end, many of the men who were working their ways down the length of the cables brought along their lunch for one last leisurely meal atop the bridge. They could take pride in what had been accomplished and in themselves as exceptional craftsmen. May 27, 1937, week-long bridge opening festivities began with the driving of a ceremonial golden rivet at mid-span. It was hammered into place by Edwin Iron Horse Stanley, the same man who drove the very first rivet on the bridge 4 years earlier. Then the multitudes clamored to make themselves part of history.
And on Pedestrian Day, which was the first day that the bridge was open, we had about 30,000 people show up and walk across the bridge, but not all of them walked. We had 2 sisters that roller skated. We have people who are very proud of the fact they were the first to run across it or ride a bike across it. We had the first horse across the bridge. That was also the last horse across the bridge because we don't allow that to happen.
On the second day of the celebration, Joseph Strauss supervised the cutting of a ceremonial steel chain, and cars were allowed to cross for the first time. It was a triumphant demonstration of people celebrating technology's ability to serve humanity's dreams. The joy was infectious. Flyovers, marching bands, and parade floats marked the triumph of a vigorous community lifting itself from the shackles of the Depression. As it turned out, the dynamic story of the Golden Gate Bridge was far from over. The original toll to cross the Golden Gate Bridge was 50 cents each way, equivalent to almost $7 today. The current toll is $5, collected only from southbound traffic. The Golden Gate Bridge will return on Modern Marvels. In San Francisco, the Golden Gate Bridge stands as a permanent reminder of one exceptional moment when dreams and determination fell into alignment. A moment that celebrated with each passing car. As of 2005, it's estimated that over 1.8 billion vehicles have traveled across the bridge. From a practical standpoint, this also makes this toll bridge an incredible economic success story.
In total, we had a $35 million construction project and then another $39 million in financing charges. That was all completely paid off by 1971, and as of now, people do not any longer have a lien on their personal property to help pay for the construction of the bridge.
For more than 3 decades, tolls have been paying for the rising costs of the bridge's administration and maintenance.
We have about 110 people at the Golden Gate Bridge involved full-time in bridge maintenance, and that includes ironworkers, painters, and a whole bunch of allied crafts, operating engineers and others. We're really a self-contained operation here. If we have to replace some steel element of the bridge, it would be manufactured right here at the bridge. We have a full fabrication shop, and almost all the parts we can build right here.
In recent decades, 2 major structural improvements have ensured the bridge's longevity. In the 1970s, all of the suspender ropes that hang off the main cables were replaced after showing signs of corrosion. In the 1980s, the reinforced concrete road deck was replaced with a steel deck.
So that what you drive on today is just a relatively thin steel plate with some ribs underneath that give it its stiffness with a very thin layer of asphalt on top. The steel deck is quite a bit lighter than the concrete deck was, and so when the steel deck was put on, the bridge actually rose up several feet.
More recent changes to the bridge were compelled by another concern: security.
In the post-9/11 world, as caretakers of an international icon like the Golden Gate Bridge, I don't think anyone can deny the fact that we might be a target to someone.
We started enhancing security here back when the first World Trade Center bombing took place in the early 90s. And certainly after September 11th, we have added people, we've added systems. It is a very safe place to be.
We've got more cameras, we've got more alarms, we've got more personnel, and we're deploying them in different ways than we ever have in the past. We actually operate as if we're on an orange alert now. We've been elevated for the last 3 or 4 years. Rather than going back and forth, we just stay at what essentially is an orange alert. The only change we would make is if we ever had to go to red alert, we do have plans we implement at that time.
Ironically, the one event that posed the biggest test of the bridge's structural integrity wasn't an attempt to destroy it, but rather to celebrate it. The bridge's 50th anniversary in 1987.
The 50th anniversary was a wonderful experience. The weather was fine. Although we had planned for 40 to 50,000 people, it was closer to 250 to 275,000 people at any one time out there on the bridge.
We had to stop transit at 5:15 in the morning because we couldn't accommodate any more people. We had both the south and north approaches jammed wall to wall with people.
34C, would you please circle the Presidio area? Our problem is the influx of people still coming in.
What was interesting is that's the greatest loading the bridge has ever seen. It carries trucks and buses and cars every day, but people packed in there, like sardines in a can, actually caused the bridge to sag. The bridge is designed to move up and down. It can go down up to 10 feet and up 6 feet, depending on temperature and loading. This tested it that day. The bridge sagged many feet, and it was visible, and some of the suspenders went slack. But it did not overstress the bridge that day, and there was no damage.
The bridge withstood the tremendous weight of the celebrating throng. This convinced experts that it was likely to stand firm through most natural or unnatural calamities. But then in 1989, the region was rocked by the shockwaves radiating from the Loma Prieta earthquake, centered 56 miles to the south. Even though the Golden Gate Bridge persevered, the city suffered widespread damage, and roadway sections collapsed on the nearby Bay Bridge. Since the Golden Gate Bridge is situated between two major earthquake faults, the Hayward Fault and the San Andreas Fault, engineers decided the time had come to make changes.
Today we know more about earthquakes and seismic engineering than they did in the 1930s. So we have a seismic retrofit program underway here at the Golden Gate Bridge. Nothing we're doing today detracts from what they did before us.
Quite frankly, they didn't know a whole lot about the mechanics of earthquakes, about the mechanics of ground motion and those kinds of things. And one of the things is that today we know an awful lot more about how the ground moves and how structures like the Golden Gate Bridge respond. And so with computer simulation and tools that they didn't have available when they designed the bridge, we're able to make the bridge an awful lot stronger without adding a whole lot of steel.
We're adding seismic energy dissipating devices to the arch so it doesn't bang into the concrete pylons. Also, we're replacing the steel towers that exist on land behind us here. Those gray towers you see are new steel towers. We constructed temporary towers or temporary supports just outside of each tower, and one at a time, we would jack up the bridge, we would cut out the old towers and install new steel towers that look similar to the old towers, but they're much stronger. They use modern ductile steel, they use modern details, modern high-strength bolts instead of rivets.
As engineers complete the bridge's seismic retrofit, they are exercising great care to ensure that the changes to the bridge are undetectable and match the original architectural style. When completed, the retrofit should allow the bridge to withstand an earthquake as great as the 1906 disaster that brought the city to its knees. This, along with the bridge's attentive maintenance and vigilant security, promises that it will endure as one of the treasured icons of the American landscape.
I don't think anyone knows exactly how long a bridge like this is going to last. The parts of the bridge that can be replaced have been replaced, and other parts of the bridge just have to be maintained. But with proper maintenance, the bridge should last essentially forever.
Today, it's difficult to imagine this turbulent stretch of sea without the Golden Gate Bridge linking the rocky shorelines. But it represents much more than an impressive engineering achievement. It stands as a tribute to the concept of community, the daring of those who erected it, and the belief that all things are possible.